Welcome back to my channel Math School. In today's video, let us solve question number 4, part 3 and 4 from exercise 3.2, chapter 3, pair of linear equations in two variables. In my previous videos, I have completed the questions 1 to 3 from the same exercise, examples 1 to 6 and exercise 3.1. If you have not watched these videos, do find the link in the description box below or click the I button above. So now quickly let us begin with the video. Third part from the question number 4, which says which of the following pairs of linear equations are consistent or inconsistent? If consistent, obtain the solution graphically. So here we have to find out whether the given pair of linear equations are consistent or not. Consistent means the two pair of linear equations will have at least one solution or more. Inconsistent means when the pair of linear equation have no solution. Okay, so first of all, let us find out whether they are consistent or inconsistent. So for that, let me write down first general form of linear pair of equations, that is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So here we will find out the coefficients a1, b1, c1, a2, b2, c2, and then we will find out the ratios of a1 by a2, b1 by b2 and c1 by c2 and find out whether the lines are intersecting, coincident or parallel. If the lines are intersecting, then we obtain a unique solution, and since we obtain a solution here, the lines are consistent. Similarly, when the lines are coincident, we get infinite number of solutions, and therefore again the given pair of linear equations will be consistent since we are obtaining a solution here. And when the lines are parallel, there will be no solution since the lines are not intersecting at any point. Therefore, we can say that here the given pair of linear equations will be inconsistent. Okay, so for that, let us find out first the ratios here. The given equations here are 2x plus y minus 6 equal to 0 and 4x minus 2y minus 4 equal to 0. So here the equations are already equated to 0, so no need to do that. If they are not equated to 0, then we have to first equate the equation to 0 and bring it general form of the linear pair of equations. Now let us find out ratios a1, b1 and c1 from the first equation. a1, that is the coefficient of x from the first equation, is 2, b1 coefficient of y is 1, and c1 the constant is minus 6. Similarly, a2 from the second equation, that is the coefficient of x is 4, b2 coefficient of y is minus 2 and c2 constant from equation 2 is minus 4. Right, now let us find out the ratios a1 by a2. What is a1 here? It is 2 by 4. So cancelling 2 1 times 2, 2 times we get 1 by 2. Similarly, b1 by b2 is 1 by minus 2. That is nothing but minus 1 by 2. Again, c1 by c2 is minus 6 by minus 4. So this minus and minus will become plus, and this will be 2 2s are 4, 2 3s are 6. So this will be 3 by 2. So here we can observe that the first ratio a1 by a2 is not equal to b1 by b2. When does this condition occur? Here, if a1 by a2 is not equal to b1 by b2, then the lines will be intersecting, having exactly one unique solution. Right? So here we have a1 by a2 is not equal to b1 by b2. Right? So therefore the lines are intersecting at a unique point, and therefore we can say that given pair of linear equations are consistent. Now since they are consistent, let us solve them graphically and find out the solution. So the first equation is 2x plus y minus 6 equal to 0. Now let us first find out the x value by sending all the other terms to right hand side. So we get 2x will be equal to, this minus 6 will become plus 6 and y will become minus y, and x will be equal to 6 minus y divided by 2. So now let us substitute for y equal to 6. X is equal to 6 minus 6 divided by 2. So 6 minus 6 is 0. So anything divided by 0 will be equal to 0. Similarly, when y is equal to 0, we get x is equal to 6 minus 0 divided by 2. So 6 minus 0 is 6 divided by 2. So 2 1 times, 2 3 times. So we got x value here as 3. Right? So let us draw the table. So for y equal to 0, we get x value as 3, and for y equal to 6, x value is 0. Right, now from the second equation given by 4x minus 2y minus 4 equal to 0. Again, let us find out the x value by sending all the other terms to right hand side. So we get 4x is equal to this minus 2y will become plus 2y and minus 4 will become plus 4. So x value is equal to 2y plus 4 divided by 4. Now let us assume the value of y and find out the value of x. Okay, so here let me assume y value as equal to 0. So x will be 2 into 0 plus 4 divided by 4. So this is 2 into 0 is 0. 4 divided by 4, cancelling 4 and 4, we get 1. Similarly, when y equal to 2, x will be equal to 2 into 2 plus 4 divided by 4. So 2 into 2 is 4 plus 4 divided by 4. So 4 plus 4 is 8. 8 divided by 4. So for 1 times 4, 2s are 8. So we get 2 here. So now let us draw the table for this values also. So we have here x and y. So for y equal to 0, x is equal to 1. And for y equal to 2, x is also equal to 2. So let us plot these values of x and y on the graph and find out the solution for the pair of linear equations. So now let us plot the graph on x-axis and y-axis. First, let us write down the scale for x-axis. On x-axis, we are taking 1 unit is equal to 1 value, right? So 1 unit is equal to 1. Similarly, on y-axis, it is the same. 1 unit is equal to 1. Now let us plot the graph for these table from equation 2x plus 4y minus 6 equal to 0. On x equal to 3, y is equal to 0. On x-axis we have to take 3 and on y-axis 0. So we get a point here. Now let us mark this point as A at 3, 0. Similarly, the second point is at x equal to 0 and y equal to 6. So x 0, y equal to 6. We get a point here. So let us mark this point as B at 0, 6. Now let us draw a line intersecting these 2 points representing the equation 2x plus y minus 6 is equal to 0. For x equal to 1 and y equal to 0, we get a point here. Now mark this point as P at 1, 0. The second point is at x equal to 0, at x equal to 2, y is also equal to 2. So here on x-axis we have to take 2 and on y-axis we have to take, we get a point here. So let us mark this point as Q at 2, 2. Draw a line intersecting these 2 points. So this line represents the equation 4x minus 2y minus 4 equal to 0. Now here you can observe that these 2 lines are intersecting at a common point, that is 2, 2. On x-axis it is 2 and on y-axis it is also. This is the unique solution obtained for the given pair of linear equation. Now let us verify this point in the equations. Now let us verify the point, that is 2, 2. That is x equal to 2 and y is equal to 2. Substitute this in equation 1. This 2x plus y minus 6 equal to 0. So substituting x value 2 into 2 plus y is 2 minus 6 equal to 0. So this will be 2 2s are 4 plus 2 minus 6 equal to 0. So 4 plus 2 is 6. This is minus 6. So minus 6 into minus 6 will be equal to 0. So left hand side is equal to right hand side and hence the first equation is verified. Similarly, let us substitute the x and y value in the second equation. So second equation is given by 4x minus 2y minus 4 equal to 0. So this will be 4 into 2 minus 2 into 2 minus 4 equal to 0. So 4 into 2 is 8 minus 2 into 2 is 4 minus 4 equal to 0. So this will be 8 minus 4 and minus 4 if you add you get minus 8. So minus 8 into 8 is 0. Left hand side is equal to right hand side again and the second equation is also verified. So this point 2, 2 satisfies the given pair of linear equation. Therefore, this point forms the unique solution for the given pair of linear equation. So therefore, we can write the point 2, 2 forms the unique solution for the given pair of linear equation. Now similarly, let us solve fourth part of the question. So again, let us write down here the general form of a linear pair of equations to find the coefficients a1, b1, c1 and a2, b2, c2. So general pair of linear equations given by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Again here these two given equations are equated to 0. So now let us write down the coefficients. So from the first equation, coefficient of x is 2, so a1 will be equal to 2. Similarly, coefficient of y is b1, that is minus 2, and constant c1 is again minus 2. Similarly, from the second given equation, coefficient of x a2 is 4 and the constant c2 is minus 5. Now let us find out the ratios. A1 by a2, here it is 2 by 4, so 2 1 times, 2 2 times, it is 1 by 2. Similarly, what is b1 by b2? b1 is minus 2 and b2 is minus 4, so this minus and minus will become plus. 2 1 times, 2 2 times, so it is again 1 by 2. And now what is c1 by c2? c1 is again minus 2 and c2 is minus 5, so this minus and minus will become plus, and we get the ratio as 2 by 5. Here you can observe that the ratio a1 by a2 is equal to b1 by b2, that is half in both the cases, whereas it is not equal to c1 by c2, right? So when does this kind of condition occur? This condition occurs when the lines are parallel to each other, and hence we obtain no solution. Since we get no solution, here the lines will be inconsistent, right? So write down, since here a1 by a2 is equal to b1 by b2 and that is not equal to c1 by c2, we can say that given lines are parallel to each other and therefore the given pair of linear equations will be inconsistent, right? So this is how we solve this question number 4. If you have any further doubts, do comment me below in the comment section. In my next video, I'll be solving question number 5 from exercise 3.2, chapter 3, pair of linear equations in 2 variables. So till then, do like my video, subscribe to my channel, and don't forget to hit the bell button below to get the latest updates of my videos, as I'll be completing the whole syllabus for class 10th SLC NCERT Math. And also do watch the related videos of chapter 3, pair of linear equations shown on the screen. Thank you.